A runtime exception happens when a particular set of conditions exists. You might not always find all of your runtime exception conditions when you're developing an application, but as you discover them during development or your users report them, it's up to you as the developer to fix them. One of the best ways to diagnose and then handle exceptions is with the try-catch architecture. Try-catch works like this. I'll start with this code in the project try-catch, where I'm declaring a variable as a data type and setting it to a value of 255, then adding 1. Because the byte data type has a top range of 255, this causes an exception. I'll remove the comments, and then I'll place the cursor before the line of code that's causing the exception. I'll type in try and press enter. This creates 3 lines of code: try, catch EX as exception, and end try. Place the code that might cause the exception after the word try. So I'll take this line and cut and paste it. Now, if that line of code triggers the exception, the flow will move into the catch clause, and you'll get a variable called EX, which is an instance of something called an exception class. Exception is what we call a top-level class or a base class, and it has a whole bunch of subclasses that are specific types of exceptions. One of the best ways of finding out what happened is to put a return statement after the catch and then add a breakpoint on that line of code. You can add the breakpoint by clicking in the gutter on the left side of the screen. You'll get this background color on the selected code. Now I'll run the application by pressing F5. That means run with debugging. And then I'll click one of my operation buttons. That results in suspending the code and dropping me into Visual Studio. The indicator on the left tells me that I'm frozen at that line of code, and I can now inspect all of my current variables in the Locals panel down here. As I mentioned previously, if you don't see the Locals panel, reset your layout. We have a variable called EX that's generated by the catch clause, and currently it's data typed as an exception. But when I look in the Locals panel and I open up the tree for EX, I see that EX is an instance of a class called system.overflowException, and I can learn all about that exception class by opening up that part of the tree, and I see the message that's associated with the exception, a data dictionary, and a lot of other information that might be useful. This particular exception is pretty simple. All you really get is this message: arithmetic operation resulted in an overflow. So to handle that exception, I'll add a little bit more code. I'll press Shift F5 to get out of debugging, and then I'll add a line of code before my return statement and output an error message. I'll use the method displayError that I coded up in an earlier movie, and I'll start with a string of addition error, and I'll append to that ex.message, the message property of the EX variable, the exception object. I'll save and run the application in debug mode again. This time I'll put in some numbers, and I'll click the plus operation. When I get dropped into the breakpoint, this time I'll click Continue, switch back to the running application, and I see my error message is displayed. Another way of handling this exception would be to correct it on the fly and simply let the application continue. So I'll comment out these 2 lines of code, and I'll click over here to remove the breakpoint, and instead I'll simply reset the value of the variable to a legal value, saying b equals 255. I'll run the application in debug mode again, I'll enter some values, and now everything works. So I can either let the user know that there's an error if it's something that the user has to deal with, or if it's something I can correct in my own code, I can add my own code in the catch section. Let's handle the other exception that I introduced into this project in an earlier movie. In this application, I'm doing a number of mathematical operations, and I introduced this possible exception when I added integer division to my calculator. I'm letting the user enter any numeric value and then doing integer division, and if they enter 0 for the second number, I'll get a runtime exception. Just as I did before, I'll add a try-catch block, and I'll move the code after the word try. Then, so I can add a breakpoint, I'll add the return statement, and I'll add the breakpoint and run in debug mode. To trigger the error, I'll enter a value of 5 and a value of 0 and click the integer division button. That gets me to my breakpoint. And I can now move the cursor over the variable, and this is another way of finding out what happened. I see that I'm getting an exception called system.divideByZeroException. Now here's another thing that you can do with try and catch. I'll get out of debugging by pressing Shift F5 again, and you can make your catch clause specific to a particular exception. So instead of saying, go into this code for any exception, I'll instead say only execute this code for a divide by zero exception. And then, before the return statement, I'll call my display error method, and I'll pass in my own custom error message, divide by zero. I'll remove the breakpoint and run the application again. Now when I enter values, including a 0 for value 2, and try to do integer division, I've handled the error and I'm telling the user what went wrong. They can then correct the problem by entering valued values. For example, I'll enter 13 and 5 and click again and I get a good result. So that's an introduction to the try-catch architecture. There's lots more to know about error handling in Visual Basic, and I encourage you to explore the documentation for the try keyword to learn all about it.